All right, welcome back. We're now in section 2, which is on balancing chemical equations, one of the most important things you'll need to be able to do in chemistry. First, I want to go ahead and start out by talking a little bit about why we need to balance chemical equations, and that is to uphold the law of conservation of matter. If you recall from section or topic 1, the law of conservation of matter or mass, both are the same, states that matter cannot be created or destroyed. So when we write out a chemical reaction, we need to make sure we write it out in such a way where we're actually showing that matter is, in fact, conserved. If you take a look at the given hypothetical beaker of reactants up here, which one down below would best represent the law of conservation of matter? The answer would be the one that has all the particles still present. So for example, if I were to take a look at my reactants and compare it to the hypothetical products in letter A, that one wouldn't be the best option, because apparently I start out with 7 of these blue dots, but I only have 4 down here, which would indicate that I've lost matter, which that's not true. If I take a look at this letter B here, and I take a look at, let's say for example, the gray atoms, okay, whatever that represents, there's 4 gray atoms that I start with, but I somehow end up having 5 gray atoms here. So I've apparently made matter, which that's not true as well. C is actually the correct answer here. If you take a look at C, you have the 7 blue dots that represent 1 atom. You have the 4 gray dots that represent another atom. And then finally you have 4 white dots, which would represent atom number 3. They may be rearranged, but the idea is you still have the same amount of matter that you started with. And so that's why we balance chemical equations. If we take a look at a chemical equation that we saw in the previous video, this was the chemical equation we looked at that had methane reacting with oxygen to create carbon dioxide and water. If you take a look at this reaction and how it's balanced, for every 1 methane molecule, there are 2 atoms or 2 molecules of oxygen that are needed. As a result, you create 1 carbon dioxide molecule and 2 water molecules. The purpose of balancing by putting the coefficients in front of the oxygen and the water is to make sure that if you look from left to right, you have the same number of atoms. So for example, I have 4 red spheres, which represent oxygen atoms. I should have 4 on this side as well. And I do. 1, 2, 3, and 4. And same goes through all the other atoms. So we balance chemical reactions so that way we are conserving all the atoms. So we could say 1 molecule of methane needs 2 molecules of oxygen to fully react and to produce 1 molecule of carbon dioxide and 2 molecules of water. We can also say, instead of molecules, we can actually say moles as well, since moles and molecules are both units of quantity. So I could also say for every 1 mole of methane, 2 moles of oxygen are needed to create 1 mole of carbon dioxide and 2 moles of water. And this is what I was talking about earlier with the mole ratio. So remember, the balanced chemical equation, which produces those coefficients, they're going to tell us not only how many molecules are needed, but also how many moles. And that'll be explained even further when we talk about chemical reactions and stoichiometry. When you go to balance, like I said, balancing is really important. There are tips for balancing chemical equations. Here's a few helpful tips. Balancing chemical equations is one of those things that it gets easier the more you do it. But when you're first starting out, you may want a few tips and tricks to help make things a little easier. So first of all, you need to write the correct formulas. If the formulas are written incorrectly for either your reactants or your products, you're not going to be able to balance, or you're going to balance it incorrectly. So you need to make sure that the formula is written correctly, and that's really important. Second thing, begin with the more complex formula. So when you're looking at a chemical equation, start with the formula that looks really complex and work your way from there. Keep polyatomic ions together. I'll come back to that in just a moment. Only change the coefficients. Never change the subscripts. We'll take a look at an example of that as well. So you can't mess with the chemical formula. You can only change the quantities by putting the coefficients or big numbers in front. Do not leave a fraction as a coefficient. All coefficients should have whole numbers. There are times when you can have fractions, but that comes later in chemistry. But for right now, your coefficients need to be whole numbers. And you need to finally double check the coefficients to make sure that the reactants and the products balance in such a way where you have the same number of atoms on both sides. More specifically, here's some other tips that I have found that make it easier. Excuse me. Number one, I always look for, are there any what I call 2-3 ratios. do those elements first. So for example, if I were asked to balance this chemical reaction that's right here, I notice that on the reactant side there's 3 chlorines, but on the product side there's 2. Same thing with the bromine. There's 2 bromine atoms on the reactant side, and there's 3 bromine atoms on the product side. So think about it. You couldn't just put one number in front of one chemical formula and then have it be balanced, right? You'd have to do something to both sides. So I always ask students, okay, when you have a 2-3 ratio, what's the least common multiple of 2 and 3? And the answer is 6, right? So I'd say, okay, what coefficient would I put in front right here to make my chlorines equal 6? And the answer would be 2. I would put a 2 there, and I'll actually do that right now just so I can show that as an example. So by putting the number 2 right in front of here, okay, that's going to now mean that I have 6 chlorines on this side. And then if I come on this side, to make the multiple of 6 with this chlorine, I'd have to put a 3 in front of here. And then same thing with the bromines. The bromines are 2 on this side, so I'd put a 3 in front of here. And on this side, there's 3 bromines, so I'd put a 2 in front of here. And if I take a look, everything else is balanced. 3 zincs, 2 aluminums, and 2 aluminums. So taking care of those 2-3 ratios will definitely help. Balancing metals next is my recommendation. Earlier I said make sure if you have the same polyatomic ion on both sides, treat it as one polyatomic. So for example, if I take a look right here, I have phosphate on the reactant side. I also have phosphate on the product side. So I'm not going to want to split that and say, okay, there's 1 phosphorus, there's 4 oxygens. Don't do that. Instead, I would just say, okay, there's 1 phosphate group right here, and then there's 2 phosphate groups over here. So how would I balance that out? Oh, I would put a 2 in front of here. That way, now my phosphates are balanced. So keep the polyatomics together if you can. Unlike in this example here, carbonate right here, do you have carbonate on the product side? No, you don't. And so in that case, you'd have to split up carbon and oxygen. And then finally, try to keep oxygen and hydrogen to the very end, I find, because they'll usually balance themselves out. So let's go ahead and do some examples. So we have example number 1 has these 3 right here. Let's go through the first one together. Okay. If I use my tips and tricks, I'm going to want to balance my, first of all, actually, I look at all my subscripts. So we have a subscript of 1, 1 and 1, 1, 2, and 2. So you notice how your subscripts are all 1s and 2s. So this is going to be one of those examples where you might have to double something, and that'll make everything balanced. Because 1 and 2, those are easy. So I got 1 zinc, 1 zinc. I've got 1 hydrogen. I've got 2 hydrogens. So I'm going to have to put a 2 in front of here to make sure the hydrogens are balanced. And now I've got 2 chlorines, because this 2 corresponds to the chlorine here. And I got 2 chlorines there. So it's all balanced by putting a 2 in front of this HCl. If I come down here, notice I've got subscripts of 1, 1 and 1, 1, 3, and 2. Now notice that 2-3 ratio. Now you may be saying, well, wait, the 3 is for the chlorine and the 2 is for the hydrogen. Even though it's for different elements, there's still a 2-3 ratio in there. So you may have a situation where you need to take care of that using our trick of using the least common multiple, which for 2 and 3, the least common multiple is 6. So keep that in mind. So take care of that one first. So, okay, to make, 6 is the least common multiple, what number would I put in front of here to make my chlorines 6? And the answer is 2. So by putting a 2 there, now I've got 6 chlorines. And to come on this side, how am I going to make 6 chlorines? Well, I'm just going to put the number 6 there. Now I've got 6 hydrogens here. What multiple here would I make this to make 6? Well, that's going to be 3. Okay, so now I've taken care of that 2-3 ratio. Do you see what I'm saying? So the hydrogens are 6 on this side and 6 on that side. The chlorines are 6 on this side and 6 on that side. The only element left that I need to check is aluminum. Aluminum is 1 on this side where it's 2 on this side. So I need to make sure I put a 2 right there. So taking care of that 2-3 ratio helped out. Finally, let's look at this last example. Notice in this last example, first of all, I always look at my subscripts to see if that'll help me out. The subscript for lead right here, Pb, is 1. Be careful, the subscript's not 3. Nitrate is NO3, but what's the subscript for the nitrate? It's the 2, right? So we have a subscript of 1 and 2, 1 and 1 each here. We have a subscript of 1 for the potassium here. Remember, nitrate's one thing, so the subscript's really 1 there. You have 1 nitrate, and then 1 and 2. So all your subscripts are 1s and 2s. So this one should actually be a fairly simple, straightforward one. So if I take a look at my polyatomics, right, I like to take care of the polyatomics because they're usually in the more complex compound first. So I've got 2 nitrates on this side, 1 nitrate on that side. And you notice how I keep them together, right? I don't split like, oh, I have, 2 nitrogens and 6 oxygens. Don't waste your time with that. I can treat this as one thing right here. So I've got 2 nitrates on this side, 1 on that side. So I'm going to put a 2 in front of here. And that's now going to make my potassiums 2. So I'm going to come on this side and put a 2 here. That way my potassiums are 2. So now my nitrates are balanced. My potassiums are balanced. And if I take a look, my leads are balanced already, 1 and 1. And we had 2 iodines on this side, but now we have 2 iodines on the reactant side because we put the 2 there. So that's my balanced chemical equation there. Now sometimes you're going to get reactions that are a little bit more difficult. So combustion reactions, which we haven't actually learned about what a combustion reaction is. Real quickly, a combustion reaction is one in which there's only 3 elements, carbon, hydrogen, and oxygen. And these reactions are it's not uncommon to have very high coefficients, like 12, 16, 25 even. And that can be a headache if you don't know there's a trick to how to balance them. So when you get to a combustion reaction, here's my recommendation. Balance the carbons first, then balance the hydrogen second, and finally balance the oxygens last. And a good way to remember that is it just goes in alphabetical order, C, H, and O. Now, sometimes as a result of that, you're going to end up having an odd number of oxygens, and you're going to get yourself into a predicament. So if that happens, and you end up having an odd number of oxygens on the product side, there's a trick. Put a decimal coefficient in front of the oxygen on the reactant side, and that's going to make it balanced, and then you just double all the coefficients. Let's look at an example so you know what I'm talking about here. Okay, so let's take a look at this one here. Balancing the carbons first, I see I have 10 carbons on the reactant side. I have 1 carbon on the product side. So to make that balanced, I'm going to put a 10 here. So now my carbons are good. Next, balance the hydrogens. I have 22 hydrogens on the reactant side. I have 2 hydrogens on the product side. So to get that balanced, I'm going to go ahead and put an 11 right there. Sorry for my handwriting. You can already see how these numbers are going to get pretty high, right? Let's take a look at our oxygens now. We only have 2 oxygens on the reactant side. Let's count how many oxygens that I have on the product side. Remember, oxygen comes in both carbon dioxide and water, so you got to keep track of that. So if I take a look at the oxygens here, 10 times 2, there are 20 oxygens. Okay, 20, there we go. And then there's 11 times 1, there's 11 oxygens here. So add those together, there are 31 oxygens on the product side. So you notice how you have an odd number of oxygens on the product side, 31. So the question is, okay, well, shoot, what number do I put here times 2 that's going to give me 31? Well, you're going to get a decimal number, right? But go with it. What number times 2 would give you 31? And the answer is 15.5. There we go. So technically speaking, okay, if I were to put a 1 right there, this is balanced. This is a balanced chemical equation. We have the carbons, the hydrogens, and the oxygens are all balanced. But the problem is we can't have a decimal number there, right? And so at this point, rather than have to like rework everything, just double every coefficient and you should actually have whole numbers. So this would become a 2. This would become a 31. This would become our 20. And then this would become 22. And that would make the reaction balance. And like I said, it's not uncommon to have very large numbers for your coefficients for these types of reactions. So keep that in mind. All right. I'm going to actually let you look at this one. So pause the video, and I want you to try doing these on your own. And then you can resume the video so you can get the answers. All right, so there's your answers. So you can double check that and see if you got those right.